Okay, so we're on chapter 7 now. We're talking about vectors as forces. We're on page 353. Two definitions we need to know is a resultant or composition of forces. And what that is what happens when two forces act upon each other. What is the resultant force? So kind of similar to when we were adding vectors before, what our resultant vector is. This time we're talking about forces. So we're going to have different types of measurement for them. The idea is going to be very similar, where we're using our triangles, our sine law, cosine law, to solve the magnitude of these forces and what angle they're being applied at. Another definition you need to know is equilibriant forces. So that's when things are sitting in equilibrium. There also can be similar to opposite vectors. Okay? So think of it, if we have two equilibriant forces, means the idea is we have two opposite vectors pushing against each other. Essentially, we have no movement between the two forces. Okay, those are two definitions you guys have there. We're going to jump to example number 2 in your textbook. Okay, and the example says that two forces of 20 newtons and 40 newtons act at an angle of 30 degrees to each other. Determine the resultant of these two forces. So we have to determine the resultant of these two forces. So we're going to draw a little diagram of what we think this might look like. Okay? Now it's good to try to do things to scale. It doesn't actually matter which force we put on the top and which force we put on the bottom. Okay? So for instance, I don't know the exact direction, but I know the angle between the two forces is 30 degrees. So I'm going to call that my 20 newtons, and we'll call this our 40. So in terms of scale, I tried to make the 41 look about as twice as long. So 40 newtons and 20 newtons, okay? And we know that the angle between the two of them is 30 degrees. So when these forces are being pushed against each other, we need to figure out what comes of it. So this idea is similar to when we were adding our vectors before. What's going to happen here is, let's say we follow our 40 newtons first, and then we apply our 20 newtons after. We're very similar to making a parallelogram the way we had done before, or a triangle in this case. Okay, so this is our new resultant force. We're going to name each of these two forces. We'll call the resultant force R. So this is our resultant force in this case, okay? And we could have called this guy force 1 and force 2. Okay? This is very similar to what we were doing before. Our force 1 that we moved over to the right is still of 20 newtons. And we know this is 30 degrees over here. So if this is 30 degrees, what is my new angle opposite of the resultant force? Anyone know? 120, not quite, 150. How did you get 150? Yeah, we subtract by 180. We know that these two angles together are going to add up to 180 degrees. So we have one of them that is 30, so we subtract that from 180 and we get 150 degrees as our other angle. Now we're going to jump in. What triangle law or trig law do I want to use in order to solve for the resultant force? Cosine law, that's right. We don't use sine law because I don't have any of the setup ratios. Okay, I don't have an opposite side and an opposite angle. So let's jump down. We're going to use our cosine law very quickly. The resultant force, or the magnitude of this force, okay, squared would be equal to, and the reason I say squared is because c squared is equal to a squared plus b squared, which is our cosine law. 40 squared plus 20 squared minus 2ab minus 2 40 times 20 cos c. And in this case, our c is our angle opposite of the side we're solving, which is 150 degrees. Okay. We're going to jump through that quickly. This ends up adding up to be 2,000 plus 800 times root 3. Now, we could have been left with a decimal. What they did to get root 3, if you look quickly in your textbook, they got negative root 3 over 2. They used a special triangle to solve what that was going to be. It's fine if you just plugged it into a calculator and got a decimal. The number you should get when you multiply all of this together is the same as multiplying 300 times root 3. Okay? When you go through it. And finally, in the end, it's funny that they did it this way. They end up putting a decimal anyways. The next number they got was 3,085.64. Okay? It's still equal to the resultant force squared. So, in order to find the absolute value of this resultant force, I need to square root what we had above. And our resultant force in this question should be 58.19 newtons. Okay. Our new resultant force is 58.19 newtons. So we jump back up. 58.19 newtons. Makes sense. Much longer than the other two. But with this resultant force, I may also like to know what angle is being applied at in terms of the horizon or the horizontal. Okay? So we assumed our 40 degrees was a horizontal line. What I want to do now is find out what this angle is going to be. Okay? And in order to find out what that angle is, I'm going to be using sine law now. I have three of the sides. We have our side, side, and side. The side that is opposite of the angle we're looking for is the 20 newtons. Okay? And we also know that this is 150 degrees, and opposite of it is 0.19 newtons. So we're going to set up sine law in order to find out what that angle is. So we'll jump down again. Sine, and we'll say A. And in this case, let's name our triangle so that we know. This will be our A, side A, angle B, side B, angle C, side C. Probably better if we zoom out. Okay. So sine A is what we're looking for. We don't know what it is. But the opposite side is 20 is equal to sine B. B, we don't know what that angle is. We know that side B is 40. And finally, sine 150 degrees divided by 58.19. Okay. So if you guys notice, I just grabbed that from the triangle. I'm going to zoom back in again to solve. Okay. Now, in order to use sine law, in order to use it to solve, I need a complete ratio, which I have here. And my goal is to figure out what sine A is, which means I don't need this middle ratio here. I can kind of drop it off of the equation. So, we're left with sine A is equal to 20. Sorry, sine A divided by 20 is equal to sine 150 over 58.19. Okay. Sine A is equal to sine 150 times 20 divided by 58.19, which ends up being, do they got an answer for me in this one? Oh, they've done theirs the other way, I think. We have to solve it. They have it different in the book. Is that what it is? Ends up being 10 degrees when we figure it all out. Alright, check it his word. We're looking at this angle being 10 degrees. Remember, in order to solve that angle, we would have had to bring sine over and use the inverse of that to whatever this equated to in order to find it out in degrees. When you're going through this stuff, make sure your calculator is in degrees, not in radians. If you're getting an answer that's very different from that, could be just a calculator problem. Okay, so roughly 10 degrees is what we're looking at here. So let's zoom out the entire page. Okay, so what this means is, in comparison to our 40 newtons or our horizontal, it's being lifted or counterclockwise 10 degrees of our 40 newtons, and the force being applied is 58.19 newtons.